Good day to you, friends and fans all over the world. This is Samuel and I can welcome you to this channel. So, this is our series on physics, our lectures on lessons so far on motion. So, we've had up to 6 lectures so far. I think this is our 7th lecture. So, in case you missed the previous one, make sure you go back and follow them one after the other. And in this lesson we'll be looking at equations of motion, how to use the equations of motion to solve problems of motion. We'll go progressively from the simple ones to the complex ones. So in this ones we'll use the equations, then in our next lesson we'll now use the graphs to solve the equations as well. So before I start, I will implore you that if you know you are not subscribed to this channel, go ahead and hit the subscribe button and also hit the like button as well. And make sure you set the bell icon, click on the bell icon and set it to all, so that whenever I upload a new lesson, you will always be notified. So, and at the end of the day, drop your comments. You will surely enjoy this lesson. So, as I go on, what are the equations of motion? The equations of motions are equations that are actually used. I'm not going to show you how they are derived, but I'm going to write them out. They are things you need to memorize and store them in your memory, so that anytime you can always come up with them. They are not difficult to memorize. They are very, very easy. It's just for you to develop some tactics. If you spend an hour, you can actually store all of them into your memory. So let me go ahead and give you the equations. So the first equation is that first and foremost, we are going to come across, let me explain the parameters in the equation. You have u. U stands for initial velocity. Then you have v. V stands for final velocity. Then you have t. T stands for time. Then you have a. A stands for acceleration. So another thing you have to know is that when you hear a word like how long will it take a body, how long usually refers to time. How long? Okay, so we move ahead. As I said, we move ahead. So the first equation is that v is equals to u plus a t. This is the first equation of motion. The second equation is that s is equals to u t plus half a t square. This is the second equation of motion. The third one is that v square is equals to u square plus 2as. This is the third equation of motion. And sometimes a fourth equation can emerge. Although with this three you can solve every problem, but let me just give you this fourth one. The fourth one is that s is equals to u plus v in brackets times t all over 2. All over what? 2. Okay. So these are the 4 equations of motion. which we'll be using in our next set of problems right now. And like I told you that U stands for initial velocity, V stands for final velocity, T stands for time, A stands for acceleration, and there was one which is here, S, which I didn't define here. S stands for the distance. So we are going to solve our first question. So let me write down the question. So this is our question. The question states that a body starts from rest and accelerates uniformly at 5 meters per second square. 5 meters per second square. This ms minus 2 refers to, is interpreted as 5 meters per second square until it attains a velocity of 25 meters per second. 25 meters per second. Calculate the time taken to attain this velocity, and also calculate the distance covered during this process, during this journey. Calculate the distance covered as well. Okay, so I'm going to add that to the question. Okay, so let me start solving. A body starts from rest. When you hear the word rest in motion, it means that the body was stationary, it wasn't moving. And for a body at rest, the velocity at that point is 0 because it's not moving. The velocity is 0 meters per second. In kilometer per hour, the velocity is also 0 kilometer per hour. So the initial velocity, because it wasn't moving, that's its initial velocity. Since the body is at rest, is what? 0 meters per second. So always when you see that word rest, always pay close attention to it. Please, whenever you see that word rest, pay close attention to it. Okay, so initial velocity, we said U, that we will always use a symbol U for initial velocity. The initial velocity is 0 meters per second. So the body started from rest. So initial velocity, it has initial velocity. Initial velocity is the starting velocity. So, and then the body does what? Accelerates. The body accelerates to accelerates uniformly at 5 meters per second. There is uniform acceleration here. The body accelerates uniformly. That means the rate at which the velocity is changing with time is constant, is uniform. So the body accelerates uniformly at, what is acceleration? 5 meters per second square. Acceleration is equals to 5 meter per second square. You can write it this way, or you can write it this way. This one is still 5 meters per second square. Okay, until it attains a velocity of 25 meters per second. It started from rest at 0 meters per second. At rest is 0 meters per second. Now it attains a velocity. It gets to a velocity of 25 meters per second. That means it started from rest, from 0. The velocity increased to 1, increased to 2, increased to 3, increased to 4, increased to 5, increased to 10, increased to 15, increased to 20, till it got to 25 meters per second. So this is the final velocity, V. 25 meters per second. And also, you can also write this one this way. Both of them are correct. Both ways of expressing the velocity. 25 meters per second can be written this way or this way. So calculate the time taken to attain this velocity. So when you have this problems of motion, what you do is that you are going to write down all the equations, or you might not need to write down all of them. You can just write down the first one. If it doesn't work, you write down the rest. So let's write down the equation. We have that V is equals to U plus AT. This is our first equation of motion. Can this equation work for us here? What do we want to calculate? They say we should calculate the time taken. And do we have all the parameters applied here to calculate time? This equation actually involves time. Can we use it? So let's look at what is supplied. They supplied us initial velocity U. U is available. They supplied us acceleration A. A is available. They supplied us velocity V. Final velocity V. It's available. And we are asked to calculate the time taken. We were asked to calculate time taken. And time is also a parameter in this equation. This is what we are asked to calculate. So that means we can go ahead and use this equation 1. There are times you might not be able to use them. You have to call up another equation. Okay? So we now substitute values into this equation. Final velocity is what? Final velocity is 25 meters per second equals to initial velocity, which is 0 meters per second, plus acceleration AT means A times T. That is acceleration times time. That is what this AT means. When you see two variables joined together directly, it means that they are being multiplied together. So that means acceleration times time. That's why we're going to treat it when we are solving. So acceleration is what? 5 meters per second square. Then T times the T, which is our time. We don't have it. We want to calculate that time, T. So at the end of the day, we can say 0 won't. This 0 is not adding anything. 0 is 0. 0 doesn't. If you add 0 to something, it doesn't increase the value. It doesn't diminish the value. It doesn't decrease the value, nor increase the value. So we forgot about that 0. We have 25 equals to 5 times T gives us 5T. So we now solve for T. So divide both sides by 5, or you just bring the 5 under here, or you divide both sides by 5. So that is going to give you 25 divided by 5 equals to 5T divided by 5. So you 5 divided by 5. 5 divided by 25 is 5. So T is equals to what? 5 seconds. Our answer is going to be in second. How do we know our answer is going to be in second? Because all our units were in SI. Our velocity was in meters per second. Acceleration was in meters per second square. Final velocity was in meters per second. So time will be in second. Our units were consistent. If any of this thing was in kilometer, we would have need to first of all convert. But since everything was supplied in SI units, there was no need for conversion. So our time here, time taken to reach this velocity is what? 5 seconds. So I also said we should calculate the distance covered during this journey. We want to calculate the distance covered during this journey. So distance covered during this journey, what does it give us? Distance covered is going to give us, let's calculate that. Distance covered S. We can't use this equation anymore because this equation here doesn't have distance. So let's bring equation 2. Equation 2 is ut plus half a t square. So the distance covered, this has distance in it, s. Already we were given initial velocity, we were given time. Sorry, we're not giving time, but we've calculated time in the first part of the question. Time has been calculated as 5 seconds, so we can actually make use of it. Since we've calculated it, we can actually make use of it. Okay, but let's assume that we had not calculated the time. Is there any equation that can help us directly? Okay, we'll get to that. Let's just use this one and see where it's going to lead us to. So we've calculated time already. We had the acceleration, we had the initial velocity. So let's go ahead and solve. So we have that distance s is equals to initial velocity is 0 meters per second. I said ut, just like at, means a times t. So ut stands for u times t. So this is going to be u is 0 times t, which is 5 seconds, plus half at squared, means half times a times t squared. So we have half times a. Our a, which is the acceleration, is 5 meters per second square. Our acceleration, which is a, is 5 meters per second square. So we have 5 meters per second square times t square. What is our t? Our t is 5. And t square, when you see something like t square, it means t times t. So in this scenario now, it's going to be, our t is 5. Since it's 5 times 5, we bring 2 5 there. Okay? So let's go ahead and solve. 0 times 5 gives us 0. So s is equals to 0 plus 5 times 5 times 5 will give us 125 divided by 2. 125 divided by 2. Okay, 0 plus 0 will not add anything. When you're adding 0 to something, it's not going to add anything, any value. The value will still remain the same. So this side will still remain the way it is. So 125 divided by 2. Let's do this. We don't need calculator to achieve this. Let me show you how you're going to get it. So this is 125 divided by 2. Just say 125, add 0.0, because 125 is odd. If it was not odd, there will be no need to add 0.0. But since it is odd, then there will be a remainder. That is why I'm adding 0.0. So 120 divided by 2. 2 here, 2 in 12. 2 in 1, it can't go. 2 in 12 is 6. 2 in 5 gives you 2 remainder 1, which you bring that remainder 1 and attach it with the 0. You combine it with the 0. That 0 now becomes 10. So you put your point. 2 in 10 becomes what? 5. So we have 2.5 kilometer. No, sorry. We have 2.5. We now attach the unit. What is going to be our unit? Is it going to be in kilometer? We are dealing with what? Distance in this question. So is it going to be in kilometer or second? For consistency of units, we've not been working in kilometer. We've been working in meters per second square, and all that, seconds. So SI unit of distance is meters. What this answer is going to carry is meters as well. If you put kilometer, you are wrong. They are going to mark it wrong for you. So the unit here is meters. So our answer, our distance is what? 2.5 meters. So our question is solved. Now, supposing we made use of another equation, are we still going to land on the same answer? The answer is yes, and I'm just going to show you that. I'm going to show you that if we had used another formula different from this one that has distance, we will still land on the same answer. So I'm going to use the third equation to illustrate that. Okay, so we got that our time was 5 seconds. Our distance right now is 2.5 meters. Distance is 2.5 meters. The time taken was calculated to be 5 seconds. So let me rub off this part so that to use the other formula, equation 3. Equation 3 states that v square is equals to u square plus 2as, and 2as means 2 times a times s. So our v square, which is the final velocity, is what? 25. So we have 25 raised to power 2. U square, u is 0, initial velocity. V is final velocity, which is 25. Let me attach the unit. 25 meters per second equals to initial velocity squared, which is 0 meters per second. This is going to be squared. This is going to be squared plus 2 times a, which is acceleration, which is 5 meters per second square, times s, which we don't know. We don't know what is the value of s. We are looking for s. We want to use another formula to calculate s, which is the distance. So what do? What are we going to do? 25 square means 25 times 25. 0 square means 0 times 0, and it is 0, plus 2 times 5 times s. 2 times 5 is what? 10. 2 times 5 is 10. Times s, you have 10s. 2 times 5 gives you 10. 10 times s gives you 10s. So 0 plus 10s, what is it? 0 is not going to influence it anyway. We still have 10s equals to 25 times 25. 25 times 25 is what? 625. Okay, 625. Okay, so we now solve for s. We make s the subject of this equation. So let's divide both sides by 10 so as to solve for s. You have to divide by 10. If you draw a 10, this 10 will disappear from here. And when you divide this side by 10, you also divide the other side by the same thing, which is 10 in this case. So you have 10. 10 cancel 10. You are left with s. Then 10 divided by 2.5 is going to be 10, divided by 625 gives me 2.5. How did I get that? In case you are confused, division by 0 is very, very simple. Let me show you here. We have 625 divided by 10. All you need to do when you are divided by 10, just put a point here. So 10 has how many 0? 1 0. Just push that point behind to the next behind the number. You put the point in front of the last digit, and then push it one place behind that last digit. So that is how we got 2.5 meters. Our unit is in meters because to ensure that there is consistency of units, there is uniformity of units, is in meters. We'll be dealing with meters, seconds, meters per second square, and the rest equals to s, just like before. Okay, just like before. So we arrive at the same answer. How about if you make use of the fourth equation, which is that s is equals to u plus v times t all over 2. You can use that by yourself and try it on your own and let us know. But I am telling you that when you make use of it, you are still going to arrive at the same answer. So I believe that you've actually understood what we've done so far. But for you to benefit more, just rewind to the beginning and take your paper and your pen and painstakingly follow. In case you have any challenge and you can't resolve, just let me know, either via the comment section or through my WhatsApp. Okay, so in case you need a one-on-one lesson, either online or offline, I'm available for it. Okay, so you can connect with me via my WhatsApp number, which is displayed there. That is plus 234 8038 5185. Okay, plus 234 8038 5185. My name is Samuel Anyekan. Okay, so you can also connect with me via Instagram, my Instagram channel, my Instagram handle, which is displayed there. Edisam number 4 real. Edisam for real. Okay, so before we go, if you know you are not subscribed to this channel, hit the subscribe button, click on the like button as well, and we are friends. Share the videos with others so that they can also benefit. What hitting this subscribe button does is that it allows YouTube to share the video to a broader audience. So thank you. We are going to mix in next class. We've just solved one question here. We're going to solve more. So God bless you as you have joined us. Bye.